Okay, we're going to talk now about functions and relations, and this is the start of chapter 2 of our textbook. So it's a new section for us, and it's called the mathematics, or the chapter heading is mathematics as a language. Okay, so we're going to learn a little bit about the language of maths, set theory, relations, functions. We start off with defining what a relation is, and you can see on your screen here a relation is just simply a set of ordered pairs. So graphically, a relation is just a bunch of points on a number plane. So that is, if we put that into a set, so in other words, just transferred each of these points and converted them into coordinates or ordered pairs, then and wrote them down separated by commas, then we'd have the set of ordered pairs, we'd have a relation. So just to write a few of them down, this might be -2, 1. This one here might be 1, 5. This one here might be 1, -2. This one here might be 4, 2, that sort of thing. So if we listed all these out, then what we've got, set of ordered pairs, that's a relation. Now a function is a relation in which no two ordered pairs have the same x value. That's the crucial element here. No two ordered pairs have the same x value. Now if we have a look at this relation here, are there any two points, any two ordered pairs that have the same x value? So let's just have a little look. We've got one here and we've got one here. So yes, we do have more than one ordered pair that has the same x value. So therefore, this is an example of a relation, but not a function. This is a relation, but not a function. Graphically, we can see this point 1, 5 and 1, -2 might be, I don't know, maybe it's this point here and this point here. So what they'll do is they'll line a vertical line. So if we can connect 2 points with a vertical line on our graph, then we don't have a function. We've got a relation, but not a function. So that defines a function, and the vertical line test tests whether graphically we have a function. So we can make that note, and we'll do so now. Okay, so I've just made a note there in the green writing, a vertical line test will test for functionality. If any vertical line intersects with the graph of the relation more than once, then the relation is not a function. So for example, let's have a look at some graphs that you will be familiar with. Let's take a straight line graph. Now a vertical line test here, if I can just do this, it's really just imagining drawing vertical lines at any point. Now if I make more than one intersection with this, then I don't have a function. However, I don't make more than one intersection, so this is a function. Because for every x value, there's a unique y value. There are no 2 points with the same x value. So let's have a look at another example, and maybe you can think of one that won't be a function. So perhaps you're thinking of a circle. Might be one example where it's pretty clear, this is okay, we don't need to make a strike, and 1's okay with the tangent, but as soon as we get into the circle, then we've got 2 strikes, and 2 strikes is out. So this is not. So a circle is not a function. However, if we just drew a semicircle, then we would be okay. We'd have a function there. So there's a couple of quick examples of testing whether a relation is a function. Clear at the moment, the distinction between a relation and a function is that a relation can be any set of ordered pairs. In fact, put anything in there at all. To test whether it's a function or not, are there any two ordered pairs that have the same x value? And the vertical line tests for that. I just want to cover domain and range. Now the domain of a function, I'll just copy this down. Okay, now the domain and range of a function. The domain of a function is the set of x values of that function, and the range of a function is the set of y values of that function. So what we can take from this example up here, for instance, then our domain will be just the set of numbers of our x values, and we'd normally write them in ascending order, so lowest to highest. It might be, if I'm just looking at these 4 points here, then it would be -2, 1, 4. That'd be my domain, -2, 1, 4. For those 4 points there. I emphasize just those 4 points. The range for just those 4 points, set of y values, 1, 5, -2, 2. 1, 5, -2, 2. So those values there are the range. Now, for a straight line such as this one, our domain here would be all real numbers. So we write that as x is an element of the real numbers, and our range, likewise, all real numbers. I apologize for screen darting around like this. Y is an element of the real numbers because we have, on this line, we have x from -infinity to infinity and also y. There are no restrictions on the domain and range. For this circle, let's say it goes from -3 to 3 here, then our domain and our range, it's not a function, but our domain would be written as from -3 to 3. So that's the set of x values. The set of y values would be identical for range.